Financial services is a highly regulated industry, and there are a lot of banks, insurance companies, fintech companies are rolling out AI. There's a lot of considerations and risk management practices that need to be looked into as this happens. We have an amazing panel to discuss these issues.
I think in certain areas of the modern market, you really can't compete if you don't have sort of a data-driven and thereby model-driven view of what's going on. I think where the limitations really come in is around interpretation and around models stop making sense if the person building the model and the person making a judgment of the model aren't in sync about what makes sense.
So basically, within the framework that we have where we capture model risks related to statistical models, what we had to do was we had to identify the additional risks that ML models pose over and above what a statistical model would pose, and incorporate procedures to mitigate those risks. To give you an example, there's infrastructure risk. You could have latency problems, you could have computational bottlenecks, you could have real-time recalibration risks in the event that you do perform real-time recalibration. It's not a problem right now, but a few years from now, I'm sure that there will be real-time recalibration.
ML models present particular challenges, the first and foremost being the difficulty of transparency, lack of explainability of the model. So that presents special challenges to the second line of defense. That's the validation team. To validate a machine learning model, because very often these models are like black boxes and they're hard to penetrate.
I think that transparency is the fundamental risk control. With transparency, and you can control risk without transparency, and people have done that in the past and perhaps for decades. But I think the fuller the transparency, the fuller the debuggability, and the fuller the potential governance. So I think that the transparency is sort of the baseline requirement, and if we have that, we can build off that in smart ways.
One of the challenges that we face, and I speak from an entire model risk management practice, looking at small organization and also big organization, but mainly for the small organization that had a very robust traditional model risk management framework that was pretty much ad hoc. Once the model is built, then the MRM team comes in and perform the validation. The challenge that we're facing now with those AI and machine learning models that needs to be deployed really quickly is that we need to come up with an agile process where developer and validator work together in addition to all of the risk control functions that are relevant to the equation.
Yeah, MLAI has already, been incorporated in various shapes and form in the banking industry. And of course, how much it's been incorporated is a bit of a function of two things in my view. The first is availability of large-scale data. The second is around regulatory concerns. And so wherever there are regulatory concerns around embracing MLAI, we've seen a little bit of a lag in embracing such techniques. But now, with new explainability techniques and the fact that more and more people are getting comfortable with these explainability techniques, these regulatory concerns are not quite as difficult to mitigate today as they were, let's say, 3 or 4 years back.
First off, algorithmic discrimination is a really serious problem and a really difficult to fix problem. Okay, it's not just going to be fixed by tech tools and technology. It's a complex socio-technical problem. So with that said, I think that fair lending groups, especially in consumer finance, have a lot of experience at hunting down discrimination and remediating it.
That's the critical piece of the puzzle when it comes to managing model risk in general. And as you rightly mentioned, machine learning models in particular just expand the risk of bias. So the approach that I use, regardless of the type of risk that I'm dealing with, is understanding, first of all, what do I know about the model that I'm dealing with, what is unclear, and what are the controls around that complexity, the piece that is unclear. And that helps shape the framework or process or procedure that needs to be leveraged to mitigate the risk. So if you think of models as being black box, right? You have what's coming into the model, you have what's coming outside of the model, and then you have that black box that you can poke into from an explainability perspective to get a sense of what's going on in the model.
The purpose of model validation is not to prove that the model is correct in the sense of a principle of physics, because no models are really correct, and particularly in finance. What validation does is decide, is this model adequate for its intended purpose? Not even the best model. Is it sufficient for purpose? As George Box put it in a famous statement, the real question is not is the model correct, but is it so wrong that it's no longer useful? And that should be a mantra for everybody working in validation.
There's a gap, in my opinion, and I'd love to hear if the other panelists agree, but we probably don't have time. Incident response is not addressed in SR 11.7. I mean, if on a close reading, it says have contingency plans, but then it moves on to the next paragraph. And so we prepare for planes to crash. We prepare for other computer systems to fail. We need to be preparing for machine learning and AI systems to fail because they can fail in complex and unpredictable ways.